This is a mini lesson for chapter 9, right? Triangles and trigonometry. You can read the main points if you'd like. You can pause and read them if you want to know what this is about. And as was true with the last mini lesson, the numbered problems are taken from the review packet, but I've changed the numbers within the problems, so they're not the same as your review packet, but they will guide you as you try those questions in your review. All right, so feel free to pause at any time. Again, I will be going through this quickly because you do have the ability to pause. So if you think I'm going too quickly, just stop it, rewind, and watch it again. All right. So use the following diagram and give it information for this problem. Okay. This is an altitude on the hypotenuse. As you see, I've highlighted the altitude, y, and the hypotenuse, 4 and 9, if you want to call it the whole hypotenuse, 13. Right there, okay? There's some important things when you're approaching this question, trying to find x, y, and z that you need to remember. All right? Here are important things 1, 2, and 3. X is the geometric mean of 4 and 13. Y is the geometric mean of 4 and 9. And z is the geometric mean of 9 and 13. These are just facts that are going to be true about altitude on the hypotenuse questions. If you were in my class, or maybe a couple other teachers' classes, we use parachute men. Okay, parachute men give you the formulas: x squared equals 4 times 13, y squared equals 4 times 9, and z squared equals 9 times 13. All right, I'm going to find x and y, and then you could probably figure out how to find z. It's just multiply those things out. But I'm going to use way number 1 to find x. Okay, if x is the geometric mean of 4 and 13, you would set up the equation like that. That's the geometric mean, right? When you talk about means and extremes, these are your means, these are your extremes. You cross multiply your means, and then times the extremes. 4 times 13 is 52. Square root. X equals the square root of 52. Well, 52 is the product of perfect square 4 and 13. We just multiplied those two numbers. So since 4 is a perfect square, that's the only thing that comes out. Broken down, x would be 2 root 13. Okay? Finding y, I'm going to do parachute men. Well, parachute men, you start at the big right angle, okay, and then you slide. The big right angle, and then you slide either down x, y, or z. For my purposes, I want to find y, so I'm going to slide down y. We say with parachute men, when you slide down something, it's exponentially fun, so you square it. When you get to the bottom, you have two options of where you want to go. I can either go a distance of 4, or I can go a distance of 9. So those are the things that I multiply together to get my equations. And then I get y squared equals 4 times 9, which is 36. Square root, y equals 6. And just to show you how this would work, how parachute men would work, had I done z, again, I would start at the big right angle. This is a different color. Big right angle here. I would slide down z, like we always say, z. Sliding is exponentially fun, so I'm going to take and square that. Okay, z squared. And then from here, you got two options. I can either go a distance of 9, or I can go a full distance. I can't go from here. I can't go from here to here. Let me show you. I can't go from there to there because I'm not at that point when I land. I land right here. Okay, I land here. I can either go 9, or I can go the full distance, 13. So that's why it's 9 times 13. Okay, you can finish that and find the answer to that, but I'm going to move on. So that is your geometric mean altitude on the hypotenuse type questions. All right, part 2 is a straightforward Pythagorean theorem. It's just a chain problem. Okay, this is a Pythagorean triples. If you remember your Pythagorean triples, there's some basic ones that you need to remember. There's 3, 4, 5. There's 5, 12, 13, which are basically the only two that you need for this problem. There's also 3, 4, 5 is related to 6, 8, 10 because 3, 4, 5 times 2 gives you 6, 8, 10. 5, 12, 13, 7, 24, 25. These are just some of the Pythagorean triples that you see on a regular basis. So I'm going to use 5, 12, 13, and 3, 4, 5. I see that if this is a 5, 12, 13, x already has to be 5. And then I look at the other triangle. Well, if x is 5, this is a 3, 4, 5, and y is 4. So x is going to be 5, and y is going to be 4. And if you and y is going to be 4. And if you know your triples, that problem takes you about 5 seconds. Okay, next question. 45, 45, 90, and 30, 60, 90. Okay? Sides in a 45, 45, 90 triangle in a ratio of 1, 1 to root 2, or leg, leg to hypotenuse. Sides in a 30, 60, 90 are in a ratio of 1 root 3 to 2, or short leg, long leg hypotenuse. Just to give you an example of what this would look like. So if the legs are 5, the hypotenuse would be 5 root 2. And then conversely, if the hypotenuse was something, in this case 8, the legs are 8 divided by root 2, or 4 root 2. Okay? Looking at 30, 60, 90, okay, you got 3 situations. Number 1, if the short leg is 5, then the hypotenuse is twice as big, which would make that 10, and the long leg is 5 root 3. So these are just some examples of what you would do given those. So if you would like to pause this and look at this and try to understand that, I could read through it, but basically you can read through it yourself and pause that. So looking at this problem, I got a 45, 45, 90 where the hypotenuse is 36. So since I know that I need to find the legs, well, the legs are 36 divided by root 2, because I know that if I take this and times by root 2, I can get to the hypotenuse, and if I take the hypotenuse and divide by root 2, I can get the legs. So in order to rationalize the denominator, I get 36 root 2 over 2, which gives me 18 root 2. So both x and y, even though it's misprinted, are both 18 root 2. All right, in this one, I gave you, again, the more difficult of the two. I know the long leg. Okay, so to get from short leg to long leg, I times by root 3. So to go backwards, I divide by root 3. So to get to x, it's going to be 27 divided by root 3. And again, I need to rationalize the denominator because I can't have a root in the bottom. So I end up with 9 root 3. Well, that's going to be x. Okay, so x is 9 root 3. Now, since this is 9 root 3, I know that if I know the short leg, I multiply times 2. Because I see that hypotenuse and short leg are in a ratio of 2 to 1, or 1 to 2. So 9 root 3 times 2 gives you 18 root 3. Okay? And again, if you want to go back to these and pause these just to kind of see some more examples of this, but this is just something that you probably practice until you're 6, so this isn't something I'm going to spend a ton of time going over, but I did want to show you a couple questions. All right, now I took sine, cos, and tan, okay? Remember, tip, sine is the opposite over the hypotenuse. Cos is the adjacent over the hypotenuse, and tan is the opposite over the adjacent. So you remember this with SOHCAHTOA. If you want to look at a little way to remember this, sine equals opposite over the hypotenuse, SOH. The cos equals the adjacent over the hypotenuse, CAH, CA. And then lastly, the tan equals the opposite over the adjacent, and that's where I get the TOA from. So if you want to remember these, they're just ratios. So the sine of angle A is going to be 24 over the hypotenuse. Well, I need to find the hypotenuse. So really quickly, I do the Pythagorean Theorem. And like I just showed you 2 slides ago, this is a triple in which x would be 25. I could solve it out and give you get that, but I know I'm going to get 25. So therefore, when I find the sine of angle A, it's going to be opposite over hypotenuse, which is 24 over 25. And what I like to do, I like to circle the angle and label the sides. So 24 is my opposite, 7 is my adjacent, and 25 is my hypotenuse. And that's going to help me set these up, because I know that sine uses O over H, so I'm going to take 24 over 25. Cos uses A over H, so I'm going to take 7 over 25, and then tan uses O over A, which is going to be 24 over 7. Again, sine, cos, and tan are simply ratios, and that's what I'm trying to get across there. Now, lastly, we're going to find the value of x, or find the value of an angle. First thing I got to do is make sure my calculator is in degrees. So if you pull up your calculator, you hit the mode button. You want to check and see that your calculator is in degrees, and this is how you're going to be able to do it. So degrees, I'm good there, so I'm going to downsize. Second thing I got to do is, if I'm finding sides, I just hit the sine, cos, or tan button. So when you figure out that your calculator is in degrees, you quit out. And if you want to find a side, I'm just going to press sine, okay? If I want to find angles, I'm going to use sine inverse, cos inverse, and tan inverse. Well, when I do that, I hit second sine, and you'll see that there's a little -1 up there, and that indicates that you're actually trying to find the angle. So for this particular problem, I'm looking at an angle. I circle it. I label the sides. This is my adjacent side. This is my hypotenuse. So I'm looking at A and H. SOHCAHTOA tells me I'm going to use cosine. And if you're like, what are you talking about? You know, that's something you could ask your teacher about. So cosine of 41 equals 7 over x, cross multiply. If you see this, basically what I end up doing is I put this over 1 and I cross multiply. So 7 equals x cos 41, or 7 divided by cos 41 equals x. So I do this in my calculator just like we were showing. So I'm going to take 7 divided by the cos of 41. And I'm okay because I'm in degrees in the clear because I messed that up. So 7 divided by the cos of 41. And it should give me what x is about 9.28. Okay? So 9.28. Now I'm going to look at number 33. Now I'm not looking for the side, I'm looking for the angle. So I'm looking for angle A to the nearest degree. And I didn't read this, it said to the nearest tenth, so this would be 9.3 for number 31 there. But find angle A to the nearest degree. I'm going to use angle A, and that's my opposite, that's my adjacent. So like we said, I'm going to use tan of angle A equals opposite 9 over adjacent 6. So angle A equals the tan inverse of 9 over 6. And I'm going to do that in my calculator. So second tan, 9 over 6. And I'm using second tan because I'm looking for angles. And it's going to give me 56.3. So to the nearest degree, I'm about 56.3. So 56 degrees. Again, when you're looking for sides, just use sine, cos, and tan. When you're looking for angles, use sine inverse, cos inverse, and tan inverse. All right, I hope this was helpful. Again, if you had any questions, you went too fast, be sure to ask your teacher, or go back and pause and try to figure these things out.